Alrighty, people, welcome back to the classroom of the interweb. Today we're looking at finding the length of a straight line. Now, looking at a straight line, you might go, without a ruler, it's a bit hard, or on a graph, might seem difficult, but we've actually got the skills already to well and truly cater to this. So, the one thing we need to remember is that this is directly related to Pythagoras. And we understand and remember that Pythagoras' theorem is c squared equals a squared plus b squared. Squared in there. Now, in the above examples, we've just solved a little bit of that so that we can find c. And if we're going to get rid of the squared there, we need to square root this side and also square root this side. So with square root, that gets rid of the squared, and square rooting all this means that we end up with square root of a squared plus b squared. So that's why that above looked a little bit different from that original c squared equals a squared plus b squared. So if we're okay with that, we're able to do that top bit fairly easily. Okay, some of the numbers might work out a bit strange, but we'll use the calculator for those ones. So square root of those. So 1 squared is 1, 2 squared is 4. So we end up with the square root of 5. And if I come over here, calculator, square root of 5, 2.24, rounded to 2 decimal places. Right, so we can go ahead and do the next one. You can have a go yourself and pause the video if you want. So 5 squared, so we're doing the squares first. 5 squared is 25 plus 49. Okay, that should equal 74. And then back again over to the calculator. Square root of 74 is equal to 8.6. Last one, 10 squared is 100. Plus 2 squared is 4. So then we have the square root of 104. And once again, square root of 104 gives us 10 points. We round that, we get 10.2. Just 2 decimal places, 10.20. Okay, so that's sort of just the arithmetic side of it. What we need to do now is get to the point where we know what these are, the 1 and 2. We can stick with that equation, that's easy. So we get to that because A is, so it doesn't matter which way we do it, but this is now a right angle triangle. If we had, like over here, we've got a grid, so it's very easy to see. But our right angle triangle is made up of this. So we just join it using a right angle triangle, and we've got side A and side B. All right, side A is made up of x2 take x1, and side B is made up of y2 take y1. All right, so we just find the distance from one to the other. So x2 is 5. 5, take away x1, which is 3. So we've got 2 there. So b is equal to 2. And then we've got 10, take away 4. Okay, so I've got the 10 from there, and the 4 from there. Okay, and we get 6 there. All right, now we've got that, we can find the length of that triangle. Because that's actually, what have I done there? Get rid of that. That's A, it hasn't changed, and that's B there. Right, so now we can pop it into our equation. C is equal to the square root of a squared, which is 2, plus the square root of b squared, 6. So we have square root of 4 plus 36. And this can be all done in the calculator. You can plug this whole thing in. I'll show you how to do that in just a tick. I'll throw this whole thing in. So square root of 40. And if we head over to our calculator now, square root of 40 is equal to 6.3. 6.3. And I'll plug it all in the calculator in one hit rather than square root of 2 squared plus 6 squared. So if you're not confident with your working out, you'll see we get exactly the same answer. Okay, so that is how we find the length of a line segment. Now, so the keys are, coming back to it, find the length of the horizontal. All right, it's basically the rise and run. Okay, that's what we're finding. We're finding the rise between 2 points, and we're finding the run between 2 points, which we've already done. So these are all old skills. So the run and rise gives us our x and y's, and then we use our Pythagoras, which can just be broken down to that right there, the rest of it. Now, for this last bit, we've got p, which is 3, 1, so I've got a point here, which is 3, 1, and I've got a point, which is 6, -5, down there. And a line between those. Please. Draw a line there. So we want to find the length of that line now. So again, x and y. So I'm going to say point A is equal to, or side A is equal to 6 minus 3. Okay, my 6, x2, x1. And my B is equal to minus 5, take 1, -5, take 1. And we get 3 and -6. Now, we have to understand that we can't have a negative length for a line. All right, so with that being the case, this is just saying that the line has gone down 6 places. All right, so it's not -6 long, so that has to be 6 centimeters, units, whatever it might be. All right, so if you get a negative, it's because it's giving you the rise or run, so it's a negative slope for this line, and that's why we get a negative value there. But we can't have a negative side length of a triangle. All right, so we've got our 2 there. So we've got the side lengths. Now we can just plug that into our equation to find C, which is the hypotenuse of the side. So over here, if we put that in there, the hypotenuse is always pointing away, opposite the right angle. Again, we're going doing that here, do that there, any way you want. Okay, there's the right angle, so that's the hypotenuse, or C. That's why we're finding C there. So C squared equals A squared plus B squared, and therefore we have 3 squared plus 6 squared, which is square root of 9 plus 36, which is 45, so the square root of 45, and we'll jump over the calculator, should be about 6.8 or something. Root, where's my square root? There it is, square root of 45 is equal to 6.71. We want to do decimal places. 6.71. Okay, so again, the keys are the equation, and we can, this one is really time. This one is already has C as the subject, so it's an easy one to use. That means you just have to find A, find B, plug it into a calculator, or do a little bit of working out yourself, and you can find the answer straight away. All right. So the other part that's key is finding the side length of A and finding the side length of B. Doesn't matter if you mix A and B around, call them. If I call this B and this A, it doesn't matter. As long as you realize that if you get a negative value, you need to turn it into a positive because it's just telling you that it's gone down 6 places. And that's basically the nuts and bolts of it. Find the difference between A. You can even count, okay? If I go right from 1 to -5, how many places have I moved? What do I have to subtract to get there? That also works. Right. So hopefully that helps you in finding the side length, the segment length of a straight line. Okay. Questions, comments, pop them down below. Hit the like button up there somewhere. If I put it up there, sometimes I forget in the videos. And have an awesome day, guys. Enjoy your school of the internet. See you, people.